I helped a lot of you in lab learn that the first line of the function now has to be the function declaration line. You can't type clear all, close all, or anything above that function declaration line or it won't work. But remember that functions are kind of weird in that you can run without outputs provided in the call, but you can't run without inputs if the inputs are used. So if you define an input and you never use it, it actually will let you run the function without calling an input. But like, why would you do that kind of thing? And then you can have 0, 1, or many inputs or outputs. And the last thing that's new with functions that many of you discovered as you started using them is that they're black boxes. That was a question in the pre-lab, which means that when you run them, they don't communicate with the workspace or the file that you're running from. So you only send something in and get something out. So all of the intermediate variables that are defined don't get saved to the workspace. Okay, any questions about that for now? Yeah.
So on that last clicker, will it print it even though you have them suppressed?
Yes, it always prints the output. Outputs are always printed unless you suppress. If I typed my func1, 1, semicolon, then nothing would be printed. Yeah. Anything else? Yeah.
If you were to want to call both result and result2, you would have to have those in square brackets, correct?
You have to put them in square brackets, yeah. Okay, so let's talk a little bit about the midterm exam. So it's kind of weird because we're going to have a whole week break before you actually take it. So just plant this in your brain and then don't erase it over spring break. Here's how the exams work in this class in general. So the only thing you may have with you at the table when you're taking the exam is 6 toolbox cards. You can write whatever you want on the toolbox cards. You can print on them. You can use front and back. There's no rules. But you can only have 6 of them. They are labeled by topic because I thought that it would be nice to organize the information by topic, but you can do it however you want. And then you can have a pencil. You can't have anything else at your table. There's no calculators, no phone, nothing. And you can have a beverage, like water or something. So that's the rules. The exam is all handwritten, so there's no computers, nothing like that. The way that the format of the exam works is summarized here. So the idea is that the first part is short answer. I give you a couple examples of that in the practice exam, but they're basically questions that are worth 1 or 2 points, and they're usually very straightforward questions like define this variable, use this variable to do this calculation. You'll see some examples of it in the practice exam. There's a section of read code where I'm going to give you algorithms to read, and then you're supposed to tell me something about it. Usually it's like, what is the value of this variable? What does the plot look like? Whatever. It's just showing that you can read code. There's another section on debugging code where I will write a code that has an error. I will run it. I will show you the error message, and I want you to find the error. All of them come from errors that I've already explained to you in this very room on this very board. So go look at those. There's really not that many. It's not going to be some bizarre error that you've never seen before. They're all things that you've seen. And then the last section, which is the most heavily weighted section of the exam, is where you will write code. And it will be a new algorithm that you haven't seen before, but a variation of something that you've seen before. People are very nervous about this section, and a lot of people get nervous because you don't have a computer to write it at, but I assure you that this is a blessing that you do not have a computer. Because when you write code, you spend most of your time debugging. You just write a bunch of stuff and then you try it. And the point of the exam is for you to show me what your thoughts are on it. It's not going to be heavily graded based off of a syntax. If there's small mistakes here and there, that I'm not going to be like, I don't run your codes, I'm reading them. So I'm looking for you to show me that you can put the right pieces together, like, oh, that's a loop, that's an if statement, and I grade them very different from the rest of the test, where I just actually line them up from best to worst. And the worst usually gets, as long as it's somewhat relevant, it's usually like a D, like a 60, and then it just gets graded up from there. The only way you get zeros on problems in my exams is if you don't put an answer. So it's like more of an essay than anything else. So I'm reading it on a more holistic level. People write these algorithms so that they're runnable. Like there's usually like 20 people who write the algorithm, and I could just type it in directly how they wrote it and it would work. So they're not difficult. That's not possible, but I'm not expecting everyone to be able to do that. I'm looking for where you are on that kind of development. So it's very similar to at the beginning of every lab or the end of the pre-lab where I ask you to go through and write the pseudocode. I'm looking for that, but it needs to be in MATLAB syntax. Not picky MATLAB syntax, but you should be writing, for loops with ends, and it should be in MATLAB syntax. So those are the sections. I think the last midterm, this was only worth 30%, so that percentage is a little bit off. But it's usually the most heavily weighted. There's going to be a binder check during the exam, so you'll drop your binders off. The description of what needs to be in the binder to get full credit is in the syllabus, so just look at it. The rubric is in the syllabus of how you'll be graded. It's out of 5 points. You'll get the binders back at the end of the exam, and your grade will already be imported. It is worth 5 points, and that is what goes towards your MATLAB binder grade. So all your pre-labs and all your labs are part of your binder grade, and then that's just another 5 points. So every pre-lab is worth 2 points, every lab is worth 2 points, and this is worth 5 points. Yeah?
We graded off of just content in it, or whether someone's signed off on it?
We don't check that things are signed off. We look for that everything is there.
I was going to say, because there are a number of times where those don't get filled out.
Yeah. Any other questions on the binder? It's really just to give you more points for all the hard work that you're doing. It's not meant to be anything else other than that. The last thing, not to sound like unwelcoming, but you aren't allowed to come into the room until you're invited. You will have an assigned seat during the exam. So we'll lay your exams out. So you need to wait until we get the exam room set up before you can come in. So just wait outside of Gaines. There's lots of room out there. You can get your binders out and get everything out while you're waiting out there. You guys have any questions about that? I'm like so ready for spring break, and I can tell that might be mutually felt, but part of life is this. Okay, so I wanted to talk a little bit about Lab 5 before we get started on today's lecture. So the Lab 5 that you did is based off of a really famous algorithm called Conway's Game of Life. And it was created by Conway, who based it off of some work from von Neumann. And it's a really, really cool algorithm that has a lot of interesting aspects, but it's relatively simple. So I just wanted to highlight a couple of the things in the algorithm in case you didn't see it on your own. So this is really small, but I wanted to just highlight a few of the pieces of the algorithm that I think everyone that I checked off, I definitely made sure that they did this. But the main thing that I saw that people missed when they wrote the algorithm is that they weren't properly accessing the correct generation. So some people were updating and changing generations at the same time. So you do have to make sure that when you count neighbors and when you check different things about the algorithm, that you're checking it entirely from the previous generation. So you can do that by just saving the previous generation quickly before you start doing those updates. But the idea is that you have a while loop, two for loops, and then an if statement nested inside, which is what everyone got to, and that's what we were looking for. If you don't have the conditions in exactly correctly, you're not going to see some of this stuff, but this is what you can see once you get the algorithm working. So the first thing is you'll see some situations within the cells that, depending on your initial conditions, that you'll get some things that are called still life. So they're things that just don't change. They stay this way. They never move. And they've been named by mathematicians and computer science people as the block, the boat, the loaf, and the beehive. And so you might have seen your solution converge to some of these shapes. There's also a bunch of things called oscillators, which I saw in lots of your solutions. And so this is called the blinker, the beacon, the toad, and the pulsar. And those will continue to oscillate back and forth forever based off of the algorithm. And again, it just depends on the solution or the initial condition that you started with. And if you just Google, I'll post this, you'll see this link when you see these slides, but Stanford has a really nice website that summarizes this, and you can get some of the conditions that make some of these different patterns. Some really fun ones that I saw in some are things that move across the domain. So they're called, they've named them gliders or spaceships. So you'll see some of those come and go in the population. Another one is called guns. I actually don't really know what, I don't really get it, but that's what it's called. It's another pattern. And then there's some really, really sophisticated patterns you can get that are really actually very beautiful. And you can do some different things with coloring the cells that also make some interesting shapes. And there's kind of like these endless different things that you can get from this very simple algorithm. In your quiz, depending on what quiz you did, I showed you how to kind of go through and do the 1D Conway's life. There's several different variations of it. And so that also has some interesting features as well, but they all only have 2 neighbors. Okay, my last thing before I get started today is just a quick tip on a common error that you've probably seen. So both of these mistakes are basically the same. I have an array from 1 to 10, and I'm accessing an element that's not defined inside the array. So here I'm accessing a 0 element, here I'm accessing an 11th, which isn't defined. But the error messages are different. You get this message if you access an element location that's either 0, negative, or a non-integer. All of them are not allowed. And you get this one when you try to access an element that is not yet defined, that's beyond the length of the array. So I wanted to show you both of those error messages. You've probably seen them before, but that's what those 2 mean. So I wanted to show you, have you guys ever heard of MATLAB Easter eggs? Okay, you're in for a real treat. I've actually seen some of you guys accidentally do them. So the one that I've seen a lot of you do is if you don't provide ImageSC with an argument, this upside down little boy shows up. And this is called a MATLAB Easter egg because programmers who develop MATLAB have these all over the place as just like jokes that if you do that these the kind of things come up. So this one's a super creepy one, but there's a lot of them. So the one I wanted to show you because you just did Conway's Game of Life is if you tape life, the algorithm is already programmed within this GUI interface. And so you can just look at it. You can see some of the things that we just talked about. So basically the programmers just incorporated. Easter eggs are not useful. They have no purpose other than just for fun. If you Google MATLAB Easter eggs, there's a ton of them. One that a lot of people like is if you type Y as many times, there's just random responses that the programmers programmed in. So I just thought you might, if you're like working late on some assignment and you're really bored, uninspired, this can get you going again. And I also wanted to show you the Game of Life because I thought that was kind of cute that that's an Easter egg. Okay, so what we're going to be talking about today is the topic on data management. So the best news is that you know how you've had to type stuff out from like a sheet or download stuff and like copy and paste arrays that I've created for you? That is no more, because now anytime I need to give you data, we're going to be using import features of MATLAB. So this topic is to show you the different ways that that works, and then the lab that you're working on is also going to have you kind of explore how to import particularly large sets of data. The data that you're going to be importing for Lab 7 has like, I think it has like 4,000 by 5,000 columns of data or something. It's just like a gigantic spreadsheet. And the idea behind most of the things that we're doing is that it just makes your life a lot easier to be able to do it in this way rather than to kind of like hard code it in and copy and paste. So MATLAB can import and export data in a variety of formats. There's a lot of different options. And I'm going to show you all the options, but the one that we use the most is called the native format. The reason that we don't talk about it until this topic is because people often confuse data files, which are extension .mat, with executable files, which are .m files. And so now that you've kind of worked through writing some of your own codes and seeing how codes run, I'm now adding in this second file format. And this is an intrinsic to MATLAB, meaning that MATLAB reads and writes these types of files really well, really naturally. So like you don't have to do much once you get it in or once you convert it out. It's just like really simple for it to read in and write out. So the import command for native files is load. And like with most things in MATLAB, there's a couple different syntax that are allowed. The one that I would encourage you to use is the one with the parentheses, which is that you just put in a string that indicates the name of the file that you want to read in. So this says filename.mat. So if you have a data file that has the name filename, you load it in with the load command. And then the export command, now I'm going to show you all of this on MATLAB, but the export command is save. And the syntax is basically the same. You just give it a file name to save to in a string in the parentheses. So it's really important that you keep track of this because now there's a couple different kinds of files that you're dealing with a single code that you're writing. So these are very different, and if you've programmed in any other language, you're probably familiar with this. But a .mat file is a data file. So it's a file that's just holding variables of data, and its only purpose is to store it. It doesn't do any calculations. It just keeps the values saved so they don't have to be recalculated, basically. And then an M file is an executable file. And that's what it's called in most other languages, is an executable file. And executable files run commands. So they have to be written in the language that the program you're running in reads. So examples of other data files would be like an Excel spreadsheet, a text file, a binary file. There's a lot of different kinds. So those kinds can all be categorized in the non-native format, which means that some other software probably created the file, or even some other instrumentation created the file. So a lot of equipment will write out files in text files, which are delimitated by spaces or commas or semicolons or dashes, and so you have to then communicate with MATLAB how your data is spaced out. So it's a little bit more work. It's not just going to be read in naturally. The one that we're going to use the most is Excel. Excel and MATLAB have grown to be work really well together. So you have to do very little to communicate with each other. Excel is really nice because it's visual, so it's human readable. So you can look at it and check to see if MATLAB's doing the same thing as it's supposed to be doing when you see it. Where other file formats that a lot of like real engineering software uses is in the form of a binary file, which is not human readable. So if you open it up, it just looks like a bunch of garbage and you don't know what it says. The reason that these files are used is because they're the smallest way to store the information as just binaries. So you'll run into all sorts of different options for that. I wanted to show you how you can locate the import-export commands for all these different formats, because I'm not going to just tell you all of them. They're all listed in the help. I don't use the help that often, but via the question mark, I just Google it. So if you search MATLAB supported file formats, or in the help just search supported file formats, there's this link that comes up. It's always the first one, which goes to the page that summarizes in a table all of the different import-export functions. So the one I gave you is the MATLAB native format, the .mat extension. And you can see here that it's listed as a load and a save for the import-export. And then if you scroll down, you'll see all these different formats and all the different functions that you can use. So for example, with a text file, it really depends on how the file was written. So if you have data that you need to read in, and by the way, this is the #1 thing that students who after taking this class or while in this class come to me for help in, is how to read in data, because that's what you're always doing. And you have to just go through and try all the different formats. So like sometimes DLM read works, sometimes TextScan works, you never know, you just have to try it and see what it reads it in as. Spreadsheets are pretty easy. It's always XLS read, XLS write. And yeah, and then there's some other ones. So specific software has specific either toolboxes or functions that you can download to be able to read them in, but this is what MATLAB comes with, is all of these. Your question?
Yeah, which one do you use for Excel?
XLS read.
XLS read.
Yeah. The read table and write table functions, people use them, but I find it very clunky, so I never use it. Question?
What did you search to get to that?
Yeah, I just searched supported file formats. So let me move over to MATLAB and show you some of the, let me show you how some of this works. So I have an XLS spreadsheet right here. I have an Excel spreadsheet right here. The first thing I wanted to point out is that a lot of you, when you're in MATLAB, I see you, you'll just double click on files from this current folder, but that's always going to try to open the files in MATLAB. So if you double click on an Excel spreadsheet, it opens it up in MATLAB, which is sometimes okay, but typically it's easier to just right click on the file and then open outside of MATLAB, or just go to your Finder or your browser in your computer and open up the file in Excel. It's much easier to see. So that's the first thing you should do with the lab that you're going to be working on. So this file just has some dates and some populations. I don't even know what this is from. I think this is from an old lab. So let's just look at how you read this in. So if I just type in the command window the read function for Excel spreadsheets, it's XLS read, and then you can start typing it in and use the tab to autofill to find the file that's in that folder, and you can just read it in. The problem is I just read it in, but I didn't give it anywhere to go. So by default, when you read in data from Excel, if you don't provide it an output to go to, because the function XLS read is just a function, it just reads it in and it saves it to that default variable ANS, but that gets overwritten. Like if I do anything, 1 + 1, ANS now has the value of the latest calculation. So when you run XLS read, you have to provide an output variable for all that data to go to. So when you run the function, you want to save it to a variable. I've chosen data as my variable, and then you'll see that a variable is created that holds that data. If we go back to the spreadsheet shows that there was 4 columns of data, and then if you look at the array that was created, it has 4 columns, and it has 101 rows, and that's because it's going to skip any headers. And that's what I mean by MATLAB and Excel working really well together. It does a lot of stuff automatically. So if there's headers or strings in your file, it just ignores them, which is really nice because you used to have to tell it exactly which cells and which things to skip. So there's 101 rows in the data. Yeah.
What if you had a space in the file name? Would it still work if you typed it into MATLAB?
MATLAB does not like spaces in its executable files. I don't know if it has a problem with data files. Yeah, it allows them because it's bracketed by the string. But yeah, you cannot have spaces in executable files because it thinks that your file name is over. Any other questions about that? Yeah.
Does that mean that you can't have strings in your Excel files?
No, I'll show you that. Your lab has strings in them because I give you the name of all the planets and you'll need to read that in. So it just does it differently. So what I'm going to do is I'm going to now, what you always do with Excel when you're reading in data is you read in everything if it's not too big, which in this case it's not. In your lab, it is too big and it takes about 30 seconds to read in. So you don't want to do this, but if it's not too big and it just takes a second to read, then you can read the whole thing in and then redefine the rows and columns into variables that are more useful. So I'm going to redefine the first column as A, and I'm going to redefine the second column as B. And so now I don't have to keep calling on and accessing the data array. I can just use A and B. And then I could do different things with the data that I just read in. So anytime I give you data from here on out, in any lab or any quiz, this is how I'm going to give it to you, either in a spreadsheet or in its native format. So let's just show, I want to show you a little bit about how the native format works. So right now I have some variables defined in my workspace. So I'm going to show you how you can write those files to a .mat file. So remember that the export command for native format is save. So I'm going to type save, and then I'm going to write out a file name that I want it to save to. So I just called it absave. And then you can provide it with the variables. Forget if you have to write it as a string or a, yeah. The variables that you would like to go to the file. If I just put this, if I just put save and then the file name, it's just going to put everything in the workspace to that file. If I indicate specific variables as second and third inputs, it will only put those variables there. So you'll notice that when you execute that command, a new file is created, a .mat file with that file name, and it's going to hold all those variable names, or all the data from those variables. So why would you do this? So if you want to save something rather than recalculate it every time, sounds bizarre now, but you're going to be writing, you could be potentially writing files in your future that take days to run or weeks to run. I wrote a script that just did post-processing. It took a week and a half to run. I just left my computer on. So I didn't want to have to run the file again to get any of those variables. So as I was doing calculations, I was exporting the results to files that I could then access later. So let's say you did that. You can clear out all your variables, and then when you type load and then the file name that you just saved, all those variables come back. And so that's what I mean by the native format just intrinsically working. I didn't have to give it a variable to go to. It just came back in as the same variable I saved it as. It all works really well with MATLAB. So anytime you only need to use your data in MATLAB, you want to use the native format. Yeah?
So would you have to type
Yes, I didn't save the variable data, so that's gone. And you don't have to bring in all the variables. So that when I said there's another syntax, this is the other syntax. Load and then just the file name without any extension or parentheses or string or the quotes. But they both do the same thing. And then if I only wanted to bring in one variable, which is also very common because sometimes there can be a lot of data and it can use up too much of your space, and so you can just bring in what you need by just calling out one or two variables. You're going to work out a lot of this stuff in your pre-lab as well. You're going to redo some of this.
Is there any way, so say you were to do this and then forget which column was variable A or which column you were sending off, can you access that map file to see what is
You can open .map files just like I did with the Excel spreadsheet and just look at it. Oh, that's loading it. How do you do that? People do it all the time. Show details? Oh yeah, I think it's right here. I just have it hidden. Oh no, I think that's just the detail of the file. Yeah, that just shows what's in it before loading it. Isn't really that useful. I guess not. I think you have to load it in, and then if you want to look at any of the variables, you just double click on them just like you do with any variable, and you can look at it. I don't know. Is there any other option? I guess not. That's what I was saying, like Excel is like visual, like you pull it up and you can see it, but the other files, file formats aren't so much. Text files are also visual, you can look at them, but they're just a little bit more difficult to communicate what the delimiter is. Let's see, anything else? Yeah.
So if you type in save and then the file name, and then don't define any variables, then everything in the workspace will be saved?
Yes. Yeah, so even if you have like the ANS variable, that gets saved there, everything gets saved there. So I hardly ever do that because that's hardly ever what you want. I always indicate what I want saved. But what's really important here is that for your lab, just for my sake, because I'm not super patient, like when I come over and you run your lab and I have to wait 30 seconds for it to read in the Excel spreadsheet file, what you need to do, and that's why I did it this way, is you need to read in the Excel spreadsheet file, get out all the variables that the lab asks for, and then export them to map files. And then when you start developing your algorithm, you're just going to read in the map file, which is super fast. So I did that purposely so you were forced to learn how to use it. If you don't do that and you just read in the Excel spreadsheet file, it takes a long time to work through the lab because every time you try it, it's like super slow. And the lab computers are really slow communicating with Excel because they work on a server. And so sometimes, just write this down in case that you run into it, some computers sometimes require you to have Excel open for the communication between Excel and MATLAB to work. Usually it is not the case. I've never seen that happen on a Mac. No offense, PCs, Macs just know what they're doing. But it does happen. And the read commands are different for Macs and PCs as well. They're a little bit different. So anyway, let me show you how to do the strings. So if you have a spreadsheet that has strings in it that you actually want to access, which you do, the planet names, when you do this call, you need to provide a second output. And what it does is it takes all of the data and puts it in the first one, all the numeric data, and puts it in the first output, and then it puts all of your string data in the second output. So you have to do this call in your lab this way in order to get those separated as well. I don't have any strings. It doesn't put headers in there. Oh, thank you. It doesn't put headers in there. It only puts columns. Lied. Definitely puts headers in there. So this is what it read in, is just the first couple rows of the file. So yeah, so you'll have to do that. And that's just a second output to the XLS read function. think that I've said everything I want. I was going to do an example, but I don't have time for that on for practice for the exam. But I think that's everything you need to know about the file formats. Remember, this isn't going to be on the exam, but also like, what would I put on the exam about this? Do you know what I mean? So it's just topics 1 through 6.